Shut up.
Okay, so welcome back. In the previous class, we were discussing trusses, the functions of trusses, how transfer the load to the supports, okay, that sort of stuff, and how the members of truss are arranged strategically so that it gives us a structurally efficient solution. So, especially like the orientation of the braces, how would you arrange your braces based on the applied load so that you can take maximum out of the truss action. That's what we discussed. Today we'll try to solve a problem and also discuss like the stability of trusses, determinate trusses, indeterminate trusses, that sort of stuff. So, one thing which we didn't discuss and which is obviously rather more commonsensical, that is that truss on its own is a structure and you can't make it stand upright. I mean a truss structure which looks something like, for example, okay, so you have got a truss structure, and this truss structure on its own you can't make it stand upright. So how would you make use of this truss in a structure? You have to make it stand in such a way that it has proper support and it doesn't fall off, or in other words, it is stable. Okay, so how would we do that? Now imagine this room. In this room you have got a frame structure, you can see. And this frame structure, how is this frame structure standing on its own? It has got some support to the left and some support to the right. So they actually don't allow it to fall off out of plane. Or in other words, out of the paper or out of the board or into the board, this structure is unstable. So you must have a structure on this side and on the other side in order to make it stable. Okay, so what do we mean? I mean, like if you have a okay, so if we have a structure and we put for example, a truss over here. I'm just showing the truss with a single line. Okay, this might be a truss like this. So we have to, and we normally put series of trusses. Okay, these trusses are connected to. The main idea is to bring the load down, okay, to the ground. That's what is going on, isn't it? You have got load at the top and that load must be brought to the ground. So we have a vertical member. These vertical members can also be trusses. Okay, so I mean the red structure I can draw. The red structure might be something, say for example, something like this. Okay, this is my red structure, and the blue structure can be a simple column or it can also be a truss. Okay, it doesn't stop us to provide vertical truss. Something like this, okay, and they both might be connected. Okay, do you understand my point? The blue structures can also be trusses and the red structure can also be trusses. Now these trusses must be arranged in such a way that, or in other words, they must be integrated in such a way that loads are properly transferred to the ground. Okay, so what do? How can that be possible? Now you can yourself realize that if this structure you place over here, you place over there, this can always fall off. Like these are like this can have a domino effect, what we call. So what can happen is that one truss can fall on another, another one can fall on another, and it can have a series of toppling down of these trusses. Okay, so we have to fit them in such a way that that thing doesn't happen. Do you understand my point? Yes. So what do? We can provide now more trusses, and these are all simple braces. Okay, the main idea is to integrate it. So let me show. So we can have, for example, something like this. Okay, you can take anything, doesn't matter, a diamond shape or whatever. But the main thing is that they should be connected with one another. And similarly, that thing can be done. Okay, so now what I have done is I have sort of make a cage out of it, isn't it? But I have made it stable. So if someone stands over here, or if someone kicks something over here, that load will be transferred. This load will be transferred to the ground. You understand my point? So how can that work? Like for example, if someone stands over here, yeah. Now look at the load path for the vertical load path. For example, you stand over here, yeah. So that load will go like this, yeah, and will come down like this and to the ground, to your foundation. Okay, is that true? That is the vertical load. You can have vertical and you can have lateral load also. So we have to see that laterally it is working or not. Okay, so laterally you can have load in this direction. That can be wind load, that can be earthquake load, which is always horizontal, isn't it? So for example, if someone is shaking it in this direction, yeah, someone is shaking it, that load must also come to the ground. So you have to check whether you have provided proper load paths. So if you are over here, for example, if I have a vertical load in this direction, what can happen is this load can go there, and then nicely through this truss action it can come to the ground. Do you see my point? If I had not provided these two members, this would have fallen off. But because of this truss action, this load can now go into there, and similarly you have got this member, this black horizontal member also, which is taking the load. So you have provided the imagine if this is my north direction. So in the north-south direction, I have provided my load path. So anyway you take lateral load, that lateral load will be taken by this, and then from here it can come down over here nicely through these trusses. Okay? Is that okay? Are you getting the mind map of what's going on? Is that okay? Please stop me if you don't understand, okay? So it doesn't mean that once I start, so I just make it a monologue and there is no one to interfere. Please stop me if you don't understand, okay? The main idea is that you get proper understanding. So we have this, in this direction, can you see that all the load is coming to the ground? Okay, so it's not essential that you have truss like this and or truss like this. You can have these braces also arranged in this manner, or you can have it in another manner. Okay, so that your load comes to the ground. Okay, so that is one way. Now, in this direction, it is working. Now, you guys are going to tell me that in the east-west direction, is the load getting transferred or not? In the east-west direction, what is the load path? Okay, don't tell me, don't give me just words, or don't just throw words at me. Tell me how the load is coming to the ground. I've told you the load path of the north-south direction. I've told you the load path of a vertical actions. But in the east-west. What is that thing which is taking the load down to the ground? Can anyone tell me?
Sir, I think there must be one more diagonal, sir.
Is anyone is there anyone who disagree with this guy? Come on, use your mind. It doesn't matter you are right or wrong. Look, we all learn from our mistakes, so it doesn't matter. There is no competition now.
Sir, this blue member will take up the
Which blue member?
Sir, because it is going inside.
Okay, so this blue member, you are reckoning that this blue member, this will take the load.
Sir, it has gone inside the plane. You have drawn it there.
This is the load, okay? This is the load. I imagine these two, I don't put it, they are just connected with one another. Okay, these are just pins. Everywhere we have got pin. So is there anything which takes the load in north-south, in east-west direction?
No, sir.
Anyone?
Sir, this corner.
Sir, east direction.
Sorry? The corner points can take the load. How? Like I've got this thing standing. Can it take load? This is just like a stick which is standing. I give a blow. Is there anything which can stop it? You have to provide a structure. What is that thing which is stopping it? So you are right that there is nothing which takes the load unless and until we provide a diagonal brace. So we have to provide some diagonal brace at the end which can go like this, and okay, or either we provide like normally what happens is that people provide at the end something like this and then they brace it up. Okay, so another structure is provided so that you have got, look, these braces will then take the load. We have provided braces in the same direction to take the load to the ground. Yeah, so in this direction we also need braces in these spaces. On these spaces we need the braces, and that's why you can't provide it in the middle, because if it's an industry, normally these type of buildings are meant to provide you a big shed. So this can be a shed where you carry out your industrial activities. Okay, you have got big machinery or things like that. So you can't provide bracing in the middle because it will stop your progress. Okay, you won't be able to your access. It will. So you don't want to hamper your access in the middle. What you want to do is to provide these braces. Again, look, you guys are engineers, so you have to think. Okay, where can I provide this brace so that I have got enough space inside, isn't it? So the only place where you can provide your braces is the ends, and that's why you see in the end, normally in the industries, right at the entrance, it's all covered. So sometime, or you might, why is it covered? Because they are hiding lots of bracing. Okay, and you can cover it also. Why? For security reasons. So you have got this area where you can brace it up and you just provide a big door. And this area also you can provide. So this structure, if it goes like this, what happens? You have, now if I have got loads in this direction, if I have got load in this direction, so this member will take all that load and transfer it to the ends. And in the ends, you have provided these bracing, and these bracing will bring it to the ground. Yes.
सर जब हमने ऊपर से लोड लगाया था,
We provided, yes.
सर नहीं
Vertical.
लोड.
Yes.
सर तो वो उस वाले लोड को ब्लू मेंबर ने ग्राउंड तक लेके गया.
Because blue member is a horizontal. देखें, simple. I have got a load in any direction. This is a load. What I have to do is provide a member in the same direction of the load. Then it will take it to the ground. So this blue member was a horizontal member. I provided the load and that load came to the ground. Okay? We are assuming that in this direction this blue member can't take the load. So you have to provide some bracing, something in the same direction. Or in slightly inclined direction, doesn't matter, but it should take the load, some component of the load in this direction.
Sir, but blue member has those bracing type.
Yeah, but these bracings, this is just like standing like this. Okay, this blue member has got load and this is standing. If I provide load like this, these are all pinned. This will fall down. Okay, you have to stop it. Either you provide a fixed connection like a frame. A frame you can provide a load like this. But these are all pins, remember? These are pins. So, therefore, in case of pins, you need some members, proper members which will bring it to the ground. These loads, if I provide it like this, like for example, if I have got a member like this, I provide a pin over here, this is also pin, and this is also pin. What will happen if I move it laterally? This will collapse. It doesn't matter whether this is a truss, this is a truss, this is a truss. Because I have pinned it over here, that's the reason. Because you have got 4 pins, it's unstable. We did it in the last class, 4 pins is unstable. So how can you make it? How can you make it stable? By providing, you can provide a member. If you provide a member like this, triangulate it. So then it can come. So that's what I've done. I can triangulate it this place. But I'm doing it, I'm doing it in small scale. This is the same thing I'm doing it in the large scale. मेरी बात इसकी समझ नहीं आ रही है? ठीक है? So that's how you guys provide your bracing in order to stabilize the whole structure. Any question? जी.
अरे जो bracing में ये भी pinned है?
Pinned, everything pinned, everything, no fixed connection. सब कुछ pinned है. Just through triangulation you are trying to bring the load down. If you provide it fixed, then it will generate moments, and you don't want moments in your trusses. So everything is pinned. Any question? Okay, is it okay? Shall we move forward? Okay, now we have this formula: B plus R is equal to 2J. This is a formula which gives you either it's a determinate truss, indeterminate truss, stable truss, or unstable truss. What do we mean by B plus R is equal to 2J? B is your bars. How many bars are there? These are the bars, okay? These are the bars. R is the reactions. How many reactions? Plus bars, okay? Is equal to 2 times joint. If this is equal, then if we have got it equal, then we have a determinate structure. If B plus R is greater than 2J, then we have an indeterminate structure, and that is not in your current course. And if your B plus R is less than 2J, then you have unstable case. So this must be greater than or equal to your 2J in order to ensure your stability. And if you get a question in exam, the first thing you have to do is apply these formulas, okay? So whether it's frame or a truss problem, the first thing is, because this will carry marks. Don't then blame me for marking you down because you haven't done these checks. I'm telling you that if you get the question, the first thing is you see how many reactions go back, because that is the first thing. If you are working in a design office and someone throw a structure at you, the first thing you check is whether it is stable, whether it's doable. You just don't close your eyes and apply some structure analysis technique and do everything, and then at the end of the day you wake up with your surprise that that structure is not working in the first place. It's unstable in the first place. So then all of your exercise that is nullified. Okay. So the first thing you check in a structure is that it is stable. Do you understand my point? Yes. So these checks you have to do firstly. And then after that, once your structure is stable, then you are satisfied, and then you go forward, do your structure analysis and whatever is up. So I'm not going to ask you that do this check also. You have to do it yourself, okay? So please I request you that you knock these things tightly into your mind, okay? These things.
So what are the B or
B is, I told you, B is number of bars. B are and J is the joints. So in this case, if we have a truss like this one, how many B's are there? B is equal to how many? 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So B is 11. Yep. R is equal to 3 reactions, one like this, and one like this. So 3 reactions and joints
7, sir?
1, 2, 3, 4, 5, 6, 7. Eleven plus 3.
14.
So 11 plus 3 is
14.
14 is equal to 14. So this is a determinate structure. Okay. So that's what. So based on this, we can say that this is determinate and it is stable. So you have to write it, and then you justify your determinate structure analysis. Okay. So that's how you do. Okay. Should I rub it off?
Sir,
Yes.
sir, I'm unable to appreciate this blue structure. This one, sir. It is going into the plane. The truss is like this into the plane.
Yes.
And thus, sir, we provide diagonal for east-west loading.
Yes.
That is also into the plane. So are they similar in shape?
Yes, look, they are, yes, you are saying that, let me do it over
Both are
here.
into the plane.
Yeah, both are into the plane, that's true. But, okay, let me rub this thing off, okay? Just this one. I'll show you what I mean. Imagine we have this type of truss. We have a truss. Please, sir, may I ask you not to talk? Imagine we have this structure which is subjected to load in this direction. That's what we have, isn't it? Yes?
sir.
Now, is this a stable structure or unstable structure?
Unstable.
Why is this unstable? Okay, I'm not applying that formula, okay? Because that formula is for one structure. It's not for the whole entity. This you have to develop your engineering judgment to tell me whether this is stable or unstable. Why is it unstable? You have got, okay, I've got a force not in this direction, over here.
Yes, sir.
I've got force over here.
Unstable.
Okay, what will happen to this force? This force will be resisted by force in this direction and force in this direction. Agreed?
Yes, sir.
Yes?
Yes, sir.
And this force, where is this force going to come from?
No way.
No way. No way.
How can this thing resist? Look, this is like you have a link. This is like this thing, okay? And you have provided a force over here, and I've made this pin, there are 4 pins. So this can go, this can fall off, okay? This can topple. So, in other words, this will become something like this. There is nothing to stop this action. So what we can do is, we can provide a bracing over here. Imagine this can be a cord or it can be a brace. Just one brace you can provide. Okay?
Yes, sir.
But or you can provide an X brace. But once you provide the X brace, what will happen? This load is now, this can be taken. Why? Because now what has happened is that your structure, the structure, you have provided this brace. Now, because of the triangulation, now it can take that load. When there was no triangulation, okay, this can fall. So that's what is going on over here. You understand now? So that's why I have provided, we must have a bracing in this direction. This, if I can, what I can do over here is also something else. And that is, what I can also do over here is, you know what? This is also pinned, but now this is stable. Why? Because I fixed this. This is now fixed. This, a moment which can appear over here, that moment can be taken by these guys. Okay? This one and this one can take that moment. You don't get the picture? Look, what has happened is, initially what we had was something like this, okay? If I have a moment applied over here, so in other words, what happens in case of frame, you get a moment, isn't it? What is that thing which stops it? That is the frame. If I tie this thing over here, okay, and if I tie it over here, then what will happen?
It will take the moment.
It will take, I just tied it. So once I tied it, okay, now what will happen? In other words, I've got this member, okay. I've got this member, okay? And this can easily move. But if I put a member like this over here, then do you think it will move?
No.
Huh? So what I'm doing is, essentially, I am providing a member in this direction and in this direction. So now look, now this thing will resist that.
Yes, sir.
This thing will resist that, and this thing will resist that, and that's what I've done. And when I do that, that's actually what I have done over here. When I do the same thing, okay, so that thing will be resisted. So that's what I have done. Okay, I've provided the member, so that's why it has become now stable.
Yes, sir.
Do you understand my point?
Yes, sir.
Is it okay?
Yes, sir.
Shall we move to the problem solving?
Yes, sir.
सर
जी
वो जो ऊपर वाले दो कॉर्नर हैं उन पे जो हमारे पास हिंज फोर्स लगी हुई है ये एक्सटर्नली हमने लगाई है
कौन से hinge?
ये वाली है
देखिए, there are two things. The external hinge, which I mentioned in my previous class, were the supports. These are actually the hinges which you apply externally because they are the boundary pins. These are all internal pins. In the truss structure, you have pins which are connected. So this thing, this is internal. By external, I mean that you have a support. So this will be placed, there would be a foundation over here. Okay, that foundation can rotate. So that's why I have made it a hinge. Okay, this foundation, if you make it fixed, like if there are mass concrete or you have got piles, do you understand what I mean by piles? Okay, so if for example I have it piled like this, so in that case this will be like a fixed connection. Why? This is like, you know, I am hammering nails in the wall. If I hammer lots of nails in the wall, what happens? A bracket which is to be attached to the wall, and that bracket has got lots of nails hammered. Okay, what happens? That becomes a sort of a fixed connection. But if you just so therefore, I mean, like if I have got a series of piles like this and a series of piles like this, so it's a fixed connection. But if I provide ordinary footing, okay, ordinary foundation like the wall foundation, that sort of stuff, that is normally a pin foundation. Why? Because this is like a pad, and pad can always rotate. It can't take the moment. So you have to make your judgment whether it is a pin or a fix. But those supports are external supports. And these ones, whatever is inside, in between these two supports, which is this one, these are all internal hinges. Okay? Is it okay? Shall we? Yes. Load path in this case?
Yes, sir.
So in this case, your load will directly come to the support like this, and okay, so this will directly come to the support because this will flow like this, isn't it? This will be lifted up. This will be tried to lift up, and this will try to be lifted down. So, if you are trying to push a frame, for example, I'm standing like this, yeah, and someone is trying to push me. So, what is happening? This leg is trying to lift off. This leg is trying to compress. So, and in reaction of that, I will have another force which is in this direction from the ground. Okay, and I'm trying to place this foot right on the ground. So I have an opposite force. So that's what is going on. Like, you know, so you're trying to push it. So this thing is trying to lift off, and this is trying to lift in. Okay? And what happens? Then in reaction, you have a opposite force which is in this direction. So this opposite force and this force will have an opposite force in this direction. So that is your load path. Okay? Is that okay? Okay, shall we move now to problem solving? I have to finish that problem. Is that okay? Shall I rub it off? So now we will use two methods. This is just a revision of what you have already done. Method of joints and method of sections. Have you done method of sections? Yes. Okay, so methods of joints and method of section, we just apply it on one problem. Okay, so this is just a revision. I told you what zero force members are. Yeah, that was in the previous class. I told you. So. Okay, so this is the problem. Okay, a very straightforward problem. You have a truss which has got two supports. One is a cable support, another one is a beam support. Okay, and you have every member. I've written 5 meter TYP, which means it's a typical 5 meter. So every member is 5 meter. Okay. Is it not visible? I'll make it a bit dark. Is it visible now? So I try to write a bit bigger. Is this visible now? This is a 90-degree angle. Okay, so first of all, we apply our equation B plus R is equal to 2J. Let's try to find out first of all whether it is what sort of structure it is. Okay, determinate, indeterminate, stable, unstable. So The first step is, okay, that is determinacy and stability. Okay, so for that I gave you an equation: b plus r is equal to j. So b is equal to 1, 2, 3, 4, 5, 6, 7. R is equal to how many? Huh? How 5? 1, 2.
There are only 3 reactions. What's that?
Six.
How 6?
The three from this one, three from that.
3 from this one.
Pin or fix?
This is spin.
The 2 from same connection.
2 and 3 from this one. Okay, so we have EX, EY. Okay, and how many from this one? Y3. This is fixed support. Okay, so if you have a fixed support, okay, I've got a fixed support and I've got a cable attached to it. Okay, so then how many reactions do I need to find?
Only 2 tension.
Huh?
What's that tension?
If I have, do I have this? This is a fixed support, okay? This is a fixed support, and in order to find out, and I've got, for example, I've got some very complex building. For example, I've got this whole NUS. Yeah, I want to lift this NUS with one string. Yeah, and that string is connected to a very fixed structure. So, how many reactions do I need to find? How many reactions will I have? How can we have 2 reactions?
One tension reaction.
Huh? Yeah, so if it sways, then
One. It can go in this direction, so I have got infinite support then. So isn't it? Because what one sway can be in infinite direction.
Yes, sir.
So I've got infinite connection. So like structure analysis doesn't address that, so then we don't need to solve it, isn't it? It's okay. We leave it, isn't it? How many supports? Come on. You have done engineering mechanics. If anything is attached to a string, so how many reactions do you have? You can have only tension. That's it. This is not a rocket science. You just have one tension. That's it. Suppose if someone is wearing a tie, okay, and you pull his tie, how much force you have applied to pull that tie? Okay, how much force is applied onto his neck? How much? So how many equations do you need? Huh? How many equations do you need? Suppose if you put a noose around someone's neck, okay, and you want to hang him. Yeah? So how much force do you need? How much force, how many equations do you need to find out the load in the string? One, that is the weight of that individual, isn't it? So what do you mean by 1, 2, 3, someone went for 5, 6? You need just one. So you have only one over here. You can divide, You can divide it into infinite components. So what? How many equations do you need to solve that? You can take it in infinite directions. That is not a concern. How many? What is the main equation you require? That is summation of force in the direction of application of force must be equal to 0. That's it. That's one equation you need. So you can find the component in infinite direction. That's up to you. If I give you any angle, you can find the inclination. So it's not that. Okay? Is that okay? So we have only T over here. So this is only T. So the reactions are 3, okay? And the joints are how many? 1, 2, 3, 4, 5. 5. So we have 7 plus 3 is equal to 10. Yes, and this is determinant. This is determinant. And you have to write it like this. Since B plus R is equal to 2J. That's why so stable. It is stable structure. Is that okay? So that is your determinacy and stability. Now we apply method of joints. Okay, so I am not going to solve the whole problem for you. I will solve few because you have done this thing. This is, I mean, like you have done this in your engineering mechanics. So method of joints. The thing which I want you to appreciate over here is, please don't just close your eyes and just apply a method. Okay, think over it. Develop your engineering judgment. And how do you engineer? How do you develop your thinking? See in which direction you can apply the least number of equations and you have got the least number of unknowns. If you start from there, okay, believe me, sometime like your labor work will reduce. Okay, you can solve a problem two ways. Either you keep it simple or you keep it hardest thing which you can find on this planet. Okay, and still you can solve the problem. Okay, so but the thing is, how do you want to do it? How do you want to do it? Okay, you know, during the space race there were two countries. One country, and they had a problem of how to do writing on the moon. Okay, I mean, like, you know, if you have to put notes, so how do you do that? One country spent billions to develop a pen, yeah, which could solve the problem. Okay, and it had why? Because in the pen you have got gravity, and because of the reduced gravity the ink doesn't come down, so you have an issue. So I mean, they developed some very sophisticated method in which the ink could come, it could counteract the gravity forces, and you can have it solved. Another country just took a pencil. So I mean, that's what I'm saying, that you can solve a problem. It's the same thing, but you make it simple. And how do you make it simple? You make it simple by looking at it. Just don't start, look at it and see how can I solve it. Okay, now I tell you, the first thing, now in here, after this, what would be your next step? What would be your next step? You have to find out reaction. Okay, so that is normally the next step. But that step is normally, what has happened? You have sort of learned it. Okay, this is not something which you have developed it through your common sense. I mean, sometimes you can solve it without finding reactions. Why? Because you just start from here. How many unknowns do you have? Okay, so 2, and you have got 2 equations. So you can find out these forces without knowing the reaction. Okay, you can do that also. But anyway, we will follow what is normally done and we find out the reactions. Okay? So in the reactions, what we have, what is Ex? So I need you guys with calculators, please, and you give me the calculations. So summation of moment moment about E is equal to 0, and what will you have? How much would this be? I told you this is 5 meters. Yeah? So T times 5 minus 30 times 10.
10, 20 times 5.
And T must be equal to T must be equal to come on, give me. Hurry up.
300 plus 100.
Is that correct? Please check it.
Yes, sir.
Yeah? Yeah, tension is like this. Huh? Yeah, because this is trying to move it in this direction and your tension is in this direction. If you have a string over here, it will take the, how will you make it in tension? Okay, so it's getting pulled and we are saying that it is at angle 90 degrees. So in other words, this two are parallel. If this was not parallel, if this was horizontal or whatever, so then you would have it, you would have required to find out the inclination. But we are saying that this is perpendicular. So T is 80 kilonewton. And how would you find out now your other two reactions? How can I do that? How can I do that?
By taking moment at the
Huh?
point C, plus sum of vertical point C.
Summation x, yes. So summation,
Angle of T with some component.
yeah. So the T,
Summation x will be cos
you have, what is this angle? What is this angle? Look guys, use your judgment. What is this angle?
45, sir.
60 degree. Why are you saying 45 or this thing? This is a symmetric. What is this? 5. So this is 60, 60, 60. Yes. Okay. So this is 60 and this is 30. How much is this? How much is this one? If this is 60, then why would this be 30?
total is 90. Set this is
30, sir, 30.
This is 60.
Yes, sir.
This, look. This will be 60 and that is 90. 90 minus 60 is 30. So you have it 30. Yeah? So this will be T cos 30. So what will be my EX?
EX equals to T cos
T cos 30. EX T cos 30. Yeah, you can.
There it is.
So 69.2.
Huh?
69.2.
And what is my EY? Summation of?
Plus 20
Fy is equal to 0. Yeah? And that is?
minus T sin 30.
EY minus is equal to
Any question? Any question? Now we solve summation. So at every joint we have two equations, okay, which is summation of fx is equal to 0 and summation of fy is equal to 0. But there are, how many equilibrium equations are there? 3. So why do we take only 2 equations? Why? Yeah, it is pin. So how is the moment 0 in pin?
No reaction.
What is that thing which is 0? In moment you have 2 things. What are they? A moment arm and the, what is that thing which is 0, which is giving you
Net force and moment.
no, in moment we have force and we have a lever arm. One of them must be 0 in order to give you 0 moment.
Summation of force is 0 because it passes through it.
Yes. The moment arm, because the pin is so small and you are applying load, although there will be a very small very small eccentricity, very minute you can have. I mean, like, you know, if I have a load over here, yeah, if the load is applied, imagine this is my pin. Okay, this is my pin, and I've got load hanging like this. Yeah, if this, okay, now if it is hanging perfectly in the center, then I agree, there is no lever. But if it is slightly off center, then there can be a very small lever. But when you hang a fan, or you hang a light, or you hang anything which is hanging, like for example, fan is not really common. Okay, so can you be 100% sure that there is no eccentricity? There can be some very small eccentricity. That is also pin section, isn't it? A fan which is hanging off the roof, that is a pin connection. But at the support, it is possible that the weight of the fan is slightly off center. Okay, slightly off center, or slightly off hook, which can have a very small moment, but that is so small that we can ignore. Okay, so that is something. Okay, but you have to think about that thing. That obviously, if your hook is not designed even for taking that small moment, then it's possible that your hook might fail. Yes, so you have to think. So this sort of small eccentricity, at least it should be able to take that. Your hooks should be able to take those type of small eccentricity. The hooks which I am talking about are the hooks which are hanging the fan. So the fan weight of the hook, yeah, will cause movement, and that small movement should be taken by the support. Okay.
Sir, is it because of that eccentricity that fans move a little?
Yes, this is because, like, you know, sometimes the fan, yes, it is because of that eccentricity, exactly. Because it's not, if it is perfect, then you have it in center. But if it is slightly off center, then you start rotating it. So, I mean, like, you know, it's not uniform, it's unsymmetrical. Yeah. You understand? So, that is, so we have, so at joint A, joint A, we have summation of forces and summation of forces in x direction must be equal to 0. So what should, okay, now the question comes, okay, the question comes, which one should I use first? Which will reduce my labor work? Yeah? Which will, so would summation of, should summation of fx be used first? And should summation of fy be used first? Fx is a smaller one. Now you have to see two things, okay? Can fx and fy give you two independent equations, two equations which are not dependent on each other? What do we mean by dependent and independent? What do we mean by that? Dependent, you have got equation which is, imagine ax1 plus bx2 is equal to c. And another one is dx1 plus ex2 is equal to f. Now these two equations are dependent. Why? Because these are simultaneous equations. Yeah, that's why I say. So, however, if I write gx4 plus x5 is equal to I. So that is independent of these ones. Okay, or either I can say, but they still have two unknowns. So for example, if there is no x5, gx4 is equal to I. This is just one equation, independent, and you can solve it. You don't need another equation. Okay, so what I am giving you is just two tips for solving it easily. Okay, and more fast, having fast calculation. So we have to see, like, which one should we? Are they both simultaneous? Then you can't have. You don't need to. Whichever you apply, summation of fx, fy, you need two equations anyway to solve that. So that is another story. But if they are not simultaneous, and you do one equation, and that gives you two unknowns. For example, I've got one equation, and this gives me two unknowns. And I've got another equation, which gives me just one unknown. So which one should I do first? This one or this one? Which one should I do first? Which one should I do first? The second one. The second one should I do first? I'll get my x2 and then I should do this one. So instead of, so you think that whether I should do this one first or this one. So in your mind, you check it whether if you do this one, you spend time and after writing the equation you realize that there is another unknown, and then you do this at the side, you find this out, and then you come back. You have lost your some time anyway. But if you are thinking about it, you do this one and then you do that one. Okay, so you are actually saving your time. Okay, so if I give you a very lengthy problem, so you can just keep on wasting your time by doing this sort of stuff and not using it, not doing it more intelligently. Okay, so that's why. So in this one, what do we have? If we do fy, look, if we do summation of fy first, then what happens? We get AB straight away. If we do fx, then we get this one and this one, two unknowns. So the best thing is we do fy. Okay, so summation of fy is equal to 0, and what will we get? We will get AB sine. So we know that when we cut it, so we always, our convention is that we take tension. Okay, we cut it and we have like these ones, the arrows pointing away from the joint. So AB Sine 60 degree is equal to 30. Yeah? And your AB must be equal to 30 by sine 60, which is
34.64.
34.
0.64.
If it is positive, that means it is in tension. Let's use common sense to see whether we really get tension or not. What do you think?
Yes, sir.
Because we are pulling it in this direction, so obviously this and this will be in tension. This one will be in compression. Okay? So we have now AB is equal to 34.64, and then we do summation of fx. And what will that be?
AC
AB cos 60.
AB
Plus AC. Plus
equals to 0.
is equal to 0. And AC will be equal to
Minus 17.32.
minus 17.32 kilonewton, and that is in compression, and it makes sense, okay, that this point is in compression. Now you can go like this or you can go like this, it's up to you. Okay, but say that you have at least two unknowns. Remember, you have got two equations and you must have two unknowns. Okay, so for example, without looking at it, if you had you started with joint C, you wouldn't have been able to solve it. Why? Because how many unknowns you would have? 1, 2, 3, 4. 4 unknowns at joint C. No. If we had started straight away from, like right from the first step, had we started from joint C, we would have had 4 unknowns and two available equations. So we wouldn't have solved it. So that's why I mean we start over here, and over here we have still 3 unknowns. So we can't come over here. So we have to go to B. So in B, how many unknowns? 2 unknowns and 2 equations. Okay, so join B. Joint B is what we have. So what should we do first? We know AB. Okay, we know AB. Now over here
BC and BD.
we have BD and BC. So what should we do? Summation of fx or summation of fy? If we do summation of fy, then
We have
Only
independent.
we have got, yes. So we have, if we do summation of fy, so we can find our BC, okay, and then from there we can find our BD. So summation of fy must be equal to 0, and that is, so BC what? Sine of
60.
BC sine of 60. Plus, huh?
BC sin 60.
Look, first of all, I told you that we always consider that this is away. Yeah? So away from the joint. So you always take it like this, and then you put in positive or negative once you are solving it. Okay, so you just take the exact value what you have found previously. So what I mean is that this one will be BC sine 60, isn't it?
Yes.
So it will be minus BC sin 60.
Y component is in negative y
So we have considered it in tension. Take minus sign with it.
What do you mean negative y direction?
Sir, BC का जो y component it's in negative y direction. So
XY coordinate system.
No, it's like I'm saying that just we haven't taken our coordinate system over here. Okay, we are not saying that this is positive y, this is negative. We are not talking about that. We are saying that BC you always consider it as tension or compression. Positive is tension, negative is compression. So I'm always assuming it as a tension. And in tension, the arrows are directed away from the point of consideration. Okay, so your B, the arrows we are always taking as away. Okay, if this comes negative, that doesn't mean that your Y is in this. We are not concerned about the coordinate system. We are not doing it in computer. Okay, when you're doing it in a software computer, then yes, you have to check the global coordinate system. In this case, I mean, we are doing it by hand. It's always away, and that is positive. Okay, so you consider it BC sine 60, and what is this? AB. Yeah, so AB sine 60. Okay, and
30 centimeters done it up.
okay.
That they will have different directions, sir. One is in tension and it is downward, and other is in tension and it is upward.
But that's what I'm saying, that once you put this thing in equation, when you're solving it, then you put the actual value which you would have already found. Okay? So you assume first of all that they are directed away, assume that everything is in tension, and then use the one which you have already calculated, put that. Use that, and you will get your signs automatically. Okay, they will be adjusted. So BC is equal to minus AB, and that is
4.64.
huh? That minus AB is why? Because we have taken it to the other side. Okay, and now this AB is plus. Okay, so AB is plus.
Yes.
So minus
The science
So इसका quadrant
sorry.
सर अगर इस तरह कह रहे थे ना कि ए बी साइन 60 के लिए बी सी के लिए हम नेगेटिव साइन यूज़ करें अभी ये पिछला मेरा क्वेश्चन था कि हम बी सी के लिए नेगेटिव साइन यूज़ करें माइनस बी सी साइन 60.
Why am I putting negatives and positives?
सर आंसर तो भी यही आ रहा है.
You can do it anyway, in any sense. Okay, you have to keep your convention, develop your convention, or formulate your convention, then you follow that. Normally, my convention is that I don't, and which is normally most common convention, I consider at a particular joint that all the members are in tension, and then I write my equation. Okay, and after writing my equation, once I work it out, okay, once I come in the form when I have to plug values, then I use the actual values which I have calculated, which is like, you know, I got from my equation BC is equal to minus AB. Now in this AB, I put the actual value which is plus 34.64, and I get minus 34.64. So you can do it anyway. but the important thing is that you follow that, you stick to that convention. Okay? So, okay, so BC is
In compression.
34.64 and that is in compression. And does that make sense? Why is BC in compression? Should BC be in compression? Why? I mean, like common sense wise, should it be in compression? Why? Why should this be in compression? So we have
कौन सा कंपोनेंट
we have got this sort of scenario, and if I move it, you have got 30 kilonewton in this direction. If I move it in 30 direction, I get compression, isn't it? And that's why I get compression.
हम टेक्निकली देख रहे हैं वहाँ कैसे
Yes, sir.
Okay? So this should be in compression, so we are okay. Okay, so at every step you can check yourself whether it's okay or not. And then we have summation of fx equal to 0. How can I do that? Summation of fx. Okay, so in case of summation of fx also, we have BC cos 60
plus BT
and BD is equal to
सर इसमें AB वाला कॉस कंपोनेंट भी आएगा
BA वाला छोड़ दिया आपने AB वाला दिया
AB cos component
okay, yes.
AB एक्सपोनेंट ऑपरेशन AB का भी पास है
Yes, but in joint B, we have got three joints, isn't it?
Yes, sir.
We have got BC, BC, BD, and AB. So when we were taking summation of F1, so we have to take AB also. So BC plus BC cos 60 degree plus BD, BC cos 60 degree plus BD
cos 60
and
AB cos 60
and this should be equal to because this tension in these two directions must be equal to this one. No, we are not doing compression. I am saying we are not doing compression over here. This is actually what is all the force which is in this direction. Okay, that is equal. Or you can take it as AB. You can take it in this direction also. take it as intention. But you see, thing is that if you have these ones and these ones, we always consider that it is directed outwardly, and then you fix it in your equation. So if these two are in this direction, they are facing this way. If this is in this direction, this is facing that way. So both are facing, so in equilibrium, they must equilibrate each other. Okay? So you can't, if you say that this is also facing this one, so this means your member is somewhere over here. I am saying that your tension is always considered out of the joint, okay, away from the joint. That's true. But you have to then tailor this idea in accordance with your equation, available equation. So when you do summation of Fy or Fx is equal to 0, all the forces on this side must be equal to all the forces on that side. If I assume that this is positive, if I assume that this is positive, for example, if I assume that this is also positive, that would mean that I am considering this arrow is actually directed in this direction, in the direction of a joint, which is not true. Do you understand my point? So it has to be tension in this direction must be equal to tension in that direction. Okay, that has to be satisfied. So if I say that, okay, so if I say this minus is positive, that would mean that I am assuming that this is in compression, okay, or the arrow is in this direction. Then it will be all positive. But that's not true. I am assuming that, so therefore I have to stick to my sign convention. So what will I get for BC? Sorry.
34.64.
For BD,
tension 34.64.
34.64 and tension. Okay? Is that okay?
Yes, sir.
34.64 kilonewton tension. So that is what we have.
Yes, sir.
Okay, yes. Just one. Now, let us test it with the method of section. Okay? I'll give you just one method of section. That's it. Okay? So, this topic. Huh? How can BD be 0? BD can never be 0. BD can never be 0. Why? Because you are pulling it in this direction, so there must be some tension over here. This will always have some tension. So you recheck it. Okay, so now if I cut it, for example, if I cut my section for method of sections, okay, for method of section, imagine I can cut it in any direction. I ask you find forces in BD. Now, why do we use method of sections and method of joints? When do we use method of joints and when do we use method of sections?
When you have two unknowns, then we use
Method of joint.
No, you will always have two unknowns in your problem. It's not.
तीन unknowns होने का method of section use करते हैं.
You can use, yes, but the thing is, like what happens is, if you want to analyze the whole truss, okay, then method of joints is easy. Okay, you just keep on doing going like this, and you will analyze the whole structure. If you are asked to find out member in a particular forces in a particular member, then you use method of section. You cut it, you draw the free body diagram, and then you take your you find the force. Now, for example, if I ask you to find out force in BD, okay, BD, so you can cut it like this. Now, how can I find out my force in BD? Using method of sections. Okay, I can take moment in point C. Yes. Why? Because the other two members, which should be included in my free body, that makes 0 with respect to C. Okay. So what you do is in method section, you take the external forces and those forces which are cut by the section. Only those forces you consider in your free body diagram and use use summation of moment on them and find out your unknown. So what we are saying is that you cut it off like this and you take, so for method of sections, just quickly, this is the last one, okay? So, force in BD. Okay, and so we take summation of moment about, C equal to 0, and that is, okay, BD times how much? BD, what do you mean AC into 30? We are talking about method of sections. AC is not coming, this is your section plane, this is the cut plane. So AC is not coming in your cut plane. This is, we are taking this for, this is a cut plane for method of sections. So AC is not coming in your cut plane. So this times C, so how much is that? You have to find out the lever arm. What is the lever arm? If this is 5 meter, what is the lever arm? What is this lever arm? If this is 5 meter, this is your 60 degrees. So this is 5
sine 60.
5 sine 60 degrees. So BD into 5 sine 60 degrees. Yes, and I told you that if I am taking cut like this, so I always assume force in this direction, okay? So my force directions are like this, okay? And I'm taking this part as my free body, not the other part. If I was taking the other part as my free body, then I would have made the arrows always away from my cut section. Okay, so that's how I solve it. Do you understand my point? Since I'm taking the left side as a free body, so I'm saying that my point is, so these arrows are away from the cut section. If I was taking this side, so then I would have taken my arrows in this direction. That's what I normally do. So this times BC, okay, and moment is,
हम external force का यूज नहीं करेंगे.
It must be equal to sir 30 times 5.
okay, it's like this, and
30
times.
opposite direction. 30 times 5 is enough.
Anti-clockwise.
So your 30 times 5 half. This is like this, and minus 30 times 5. So minus 30 times 5 must be equal to 0, and BD is equal to kilonewton in tension. That's how. Okay? Is that okay? That's it. Thank you very much. Thank you.
CD के लिए